Good afternoon, YouTube. Just a quick update here on diversion load. I finally hit some conditions where both sides are working. And yeah, I'm trying to figure out if this is actually working right or not. It looks like, yeah, everybody's ramping up because I've got excess power on line 1 and excess power on line 2. So they were both starting up trying to use negative power on each side or sharing the diversion load. But this is a case where they can't because there was no load on either side. There's some clouds blowing over today. The solar power's been going up and down, and this is the first time we've had excess power. Now it looks like line 2 is sending power to line 1. So now we've got the house power down to about 7 watts. I just wanted to look here. So yes, the refrigerator kicked on. And we're actually bringing in 353 watts on the grid tie system. That's why we had a lot of extra power here. And then likewise this hybrid inverter power, so that's over here. Wow, bringing in 1130 watts, putting 28 amps into the battery and 182 watts into the load that's directly connected to the inverter. So you've got roughly 95 plus 73, 160, 170 watts total, and then that's feeding into line 1 or offsetting the power on line 1 and driving the whole house down to 7 watts. Once it zeroes in on the amount of power coming in and the amount of various loads taking power out, it settles down pretty good. Here's the solar or PV power output graph from the hybrid inverter, and so this is the month of July. This was sort of the normal amount of power that was brought in, anywhere from, this was like a cloudy day, 4.27. It's running right around 5 kilowatt hours per day. And then this day here, the 27th, I just put the sharing code in there and was testing it out. Both these days here, the 26th and 27th, were fairly cloudy, and I was able to bring in over a kilowatt hour more. And then the 28th, I left the diversion load with sharing mode on most of the afternoon. I had it turned off a little bit. I'll show you that. That's the highest day I had all month, 6.33 kilowatt hours. So this is an hourly shot of the PV solar input power. And you can see my solar panels about 9:30, they get the sun. The sun moves around the trees that are off to my east and hit the panel, and then pretty much up until around noon. This day was a little bit cloudy, so it was a little after noon that I hit peak power, about a kilowatt. And then once the battery's charged, the power drops off. I think this was probably running some loads in the shop. The inverter was powering that. And then it just sort of tapered off during the day. So if you ignore that blip there, the power that was collected just sort of tapers off until about 8 o'clock, and then the sun's over the horizon. Now, if I turn on the diversion load, like I did on the 28th, early morning I don't get a lot of power, and then it steps up here again by, roughly 9 o'clock. We had some clouds here, and then the clouds burned off, and we hit the peak power, and I had the diversion load with the sharing mode on, all except for about maybe 30 minutes or an hour here. This chart is filled out completely, except for that hole in the middle where I turned it off. This was the normal amount of power I'd be bringing in, but with the sharing mode, I was pumping all of this power into the house loads, the before and then the after. It's just dramatic, and that brought in just about a kilowatt hour of extra energy. I did another relationship graph showing the share mode and assist mode conditions that I added. That part is controlled by this switch. So this is switch position number 3, turns on this whole house diversion load, and that feeds this share condition. So that's how I can turn this condition on and off. And then both these two conditions, the share and the assist, looks at what's going on line 1, and then it computes a number here, and it computes a number here, and then my original code just looks at line 2 power and then the watts per step. And it just says, what do I have to do for the current line 2 power? How do I get rid of excess power on line 2? This says, can I use any excess load on line 1? And this one says, can I help line 1 diversion load if it's overloaded? And then they take the current setting, and I add this number and this number and this number together. This is always positive here. This goes from 0 to 100. This can go from minus 100 to plus 100. Again, these are floating point numbers. They can be anything, and they just add up all 4 numbers. You come up with a new setting, and then it goes to the original code that says, is the new setting different than the old setting? And if it is, it changes the load. And if it isn't, it just restarts the timer here. All I added were these 2 conditions. So this is 1 line of code. That's 1 line of code. And then this one has 2 extra things that it adds up. And then there's just this device property. Quite a powerful environment in that P-leg. I've been looking at the reactor automation package on Vera, and I think you can do all of these things, except the one thing I don't know about is if reactor supports timers. They have expressions and conditions and actions. I forget what they call their actions, but yeah, if anybody has any input on that, post up in the comment section below. And there we got both of them running now. We have excess power on line 1 and excess power on line 2. So both diversion loads have to kick in. So this guy will go up. Yeah, he went up to 8. Now this one is maxed out up here. That's probably way too high. Yeah, so this one should probably drop. Yeah, that's the highest I've seen at 88%. Oh, wow, up to 94%. Yeah, I think the solar power fell, so the grid tie power here dropped, so there's more load here. And now I can pump all of this excess power into line 1 and not have to dissipate anything. So yeah, that worked right there. It has a little bit of trouble, when things are changing very quickly. But yeah, I just thought I'd show you that. Both loads working at the same time and trying to keep things under control. Right now we've got negative on both sides. So this guy jumped up, that guy jumped up. Oh, there we hit 100. This one probably jumped up a little bit. I'll have to look back on the video. So this side is maxed out. See, that one bumped way up to help out this one. Now this one should drop off because it's not maxed out again. There it goes. So there was my assist mode. So that works. Now they're both going to have to turn on again. That'll go up there. Oh, this one hit 100 again. So you can see this guy is maxed out. And we've still got negative power here, so the load on line 1 is helping, trying to use up that excess. Oh, wow, look at that. Yeah, 13. That is almost full power. I think 1340 is the rated output of the panels. So that is almost peak power. This guy is peaked out, and we're still getting 120 watts excess. So this guy is kicking in and keeping the house power at 13 watts. That's the assist mode working. So anyway, good that we caught the assist mode working. It seems like it kicks in when it's supposed to, and then it turns off when it's supposed to. So yeah, I just thought I'd show you that mode working. I hadn't had a chance to test it, but yeah, with the crazy sun and clouds today, we got a chance to see it working for a little bit there. So anyway, hope you enjoyed that. If you have any questions, post up in the comment section down below. And as always, thanks for watching.